Welcome to the Crazy Hat Chemist. So another video here on solubility. So let's get moving. Bam! Today we're talking about solubility example number 1. Knowing the solubility of plumbous sulfide, that is lead to a sulfide, at 1.8 times 10 to the negative 14 molar at 25 degrees Celsius. Calculate the KSP. All right, so let's see what we can do here. So we're going to write the equation here, the balanced equation for the dissociation of plumbous sulfide, and we're going to do an ice table. Okay, so here is plumbous sulfide. That is a solid, and it dissociates to a plumbous ion. That's a lead 2+ ion. That's aqueous, and a sulfide ion, and that's also aqueous. Notice that the charges are both 2+ and 2- for the lead and the sulfide respectively. The sulfide is a periodic trend charge, and the plumbous is the 2+ as opposed to the plumbic, which is a 4+. We're going to do an ice table. So that is the initial, the change, the equilibrium. Okay, now when we are doing the KSP expression, what are not included here? Solids and liquids. Solids specifically is not included, so we really don't care about the solubility or the concentration of the plumbous sulfide, the solid, because it's not included in the K expression, so we can actually ignore that. So that's why we're going to draw a line right there. Okay, so what are the initial concentrations of the lead and the sulfide respectively? That would be a 0 and a 0. Okay, just like we have done for every single equilibrium equation thus far. All right, now the change. So again, we don't have to worry about the lead sulfide because that is a solid, so no worries there. Okay, and then the equilibrium will shift to the right. That is, we're going to add a 1x and add a 1x. We're using the stoichiometric coefficients from the balanced equation. That is a 1 in front of the plumbous and a 1 in front of the sulfide, and the variables x. We're going to now draw a line in the sand. That is, draw a line in between the change and the equilibrium and add up the initial and the change to get the equilibrium values. Of course, we don't care about the plumbous sulfide solid, because that's not included in K expressions, and now we have x and we have x. So now what we need to do is we need to write the KSP expression for this. So we're going to write the KSP expression for this. That is products over reactants with the stoichiometric coefficients as exponents. Solids are not included. So I got KSP is equal to a lead 2+ in brackets times sulfide 2- in brackets. They're both aqueous. They both have exponents of 1s. Okay, everything good so far, hopefully for you. Now, I am most interested in the equilibrium concentrations and those equilibrium values. Okay, all right, so I'm going to be plugging into that. So that is x and x, right? The lead, the plumbous, is in x. The sulfide is an x, so therefore they're both x's. So we got to simplify this, and x times x, that is 1. The exponent of 1 and the exponent of 1, we're going to add those up together, we get x squared. So what is x? X is actually the solubility. So when we solve for x, that is the solubility. We are given the solubility in this particular problem. That's 1.8 times 10 to the negative 14. Okay, and the solubility is equal to the lead ion concentration and the sulfide ion concentration individually. So that is also going to be plugging into the KSP expression in terms of x. So what is x? Well, it's given to us. X is 1.8 times 10 to the negative 14 molar. That is the solubility. That is equal to x. So now I need to plug this value into the KSP expression. So I'm going to plug this in for x. That is, KSP is equal to 1.8 times 10 to the negative 14 squared. So all you got to do right now is plug this into your calculator and square the 1.8 times 10 to the negative 14, square that, and you're going to get the KSP. And there it is. The KSP is equal to 3.2 times 10 to the negative 28. Okay, you should notice something here about this. The KSP is less than 1. Okay, and that is always, KSP expressions are reactant favored, so this should make sense. Okay, we don't have to do an ice table, but we are doing an ice table for every single one of these because these are equilibrium problems. We don't have to write the solid. We're ignoring the solid because, of course, it's a KSP. All right, that is an awesome video here, and I got a great hat for you. I am the Crazy Hat Chemist wearing a crazy cat hat. Isn't that cool? I love it. You gotta love that. Don't forget to donate to my website, and you might even get a sticker. Donate to my website, maybe a little bit more, and you might get a cool t-shirt here with my logo, and on the back there is my website. Okay, if you like that video, give me a thumbs up, subscribe to my YouTube channel, and please pass it on to all your cool chemistry friends who need some help. I'll see you next time. Bye for now.